The global pickup truck market is changing faster than many expect. While traditional brands increase prices, complicate their mechanics, and raise maintenance costs, Chinese manufacturers advance with a different strategy: more accessible pickups, produced on a large scale and designed for real use in work, fleets, and daily transport. It is not just about copying existing models, but about occupying the space left by vehicles that became too expensive for the average user. In 2026, this movement is not a promise for the future. It is a reality that begins to redefine what can be expected from a mid-size pickup in terms of price, equipment, and total cost of ownership. 5. Great Wall Poer, the Chinese pickup that understood real work. Great Wall did not design the Poer to impress at an auto show. It designed it to sell volume in markets where the pickup is a work tool rather than an aspirational object. And that difference is not minor. When a brand decides from the beginning who it manufactures for, everything changes: the chassis, the engine, the equipment, the price, and even the service network. The 2026 Poer is the evolution of that logic. It is not a reinvented pickup. It is a pickup that was perfected within a philosophy that has already proven to be viable. What exactly is the Poer? It is a mid-sized truck built on ladder-frame chassis, with real 4x4 traction and known architecture diesel and gasoline engines. There are no technical experiments. There are no electrified platforms that generate maintenance doubts. There are no semi-autonomous driving systems requiring specialized calibration every 20,000 kilometers. There is the industrialization of a formula that has already proven to work, executed with the efficiency that Great Wall has been building for over 2 decades, manufacturing vehicles for cost-sensitive markets. The Poer exists because the global pickup market became too expensive. Hilux, Ranger, Amarok, and similar vehicles increased in price due to technical complexity, emissions regulations, and equipment escalations that most work buyers did not request. Base versions of those pickups disappeared or became fleet products without retail access. The versions sold in dealerships carry touch screens, driver assistance systems, and electronic suspensions that raise the ownership cost in an unending cycle. Great Wall saw that gap and entered with a clear proposal: a more accessible pickup to manufacture, with acceptable comfort standards for 2026, but without the extreme sophistication that triggers high maintenance costs. Now, what does "without extreme sophistication" mean in concrete terms? It means the Poer does not have a multi-link rear suspension. The technical base is classic: ladder chassis, independent front suspension, and a solid rear axle with leaf springs. This configuration has critics in the automotive journalism world. It is said to penalize comfort when empty, causing the pickup to bounce on smooth roads when it carries no load. And that is true, but that criticism ignores the real usage context. A pickup marketed as a tool is not empty most of the time, it is loaded. And under load, the solid axle with leaf springs is exactly the correct solution. It supports real weight, withstands bad roads and intensive use without the chassis beginning to flex critically or suspension components giving way prematurely. This is no coincidence. It is an engineering decision oriented toward the customer who will use that pickup for what it was designed for. A builder who uses his pickup every day with 800 kilos in the bed does not want a complex suspension. He wants a suspension that does not fail. The Poer's turbo diesel engines aim for balance between torque and fuel consumption, not sporty performance. And that is also the right decision for the segment. In real use, what matters in a work pickup is torque at low revs to move loads, not acceleration when empty. No one tows a trailer and says how well it accelerates from 0 to 100. What they say is how well it climbs the hill without the engine complaining. That sustained, constant torque available from low engine speeds is what the turbo diesel delivers better than any other engine architecture in this segment, and there is another factor rarely mentioned in reviews. The engine works many hours under constant load in extreme temperature conditions. There, thermal robustness and tolerance to imperfect maintenance matter more than lab specification numbers. An engine that delivers 200 horsepower in the lab, but requires synthetic oil of a specific specification, changed exactly every 10,000 kilometers to maintain warranty, does not work in a market where technical service is 400 kilometers away and the available oil is generic. Great Wall's approach is clear and can be summarized in 3 words: total cost of ownership. cheaper spare parts, known mechanics for generalist workshops, and moderate electronics to avoid dependency on ultra-specialized diagnostics. It is not the most refined pickup in the segment. It does not have the interior finish of a Ranger nor the connectivity technology of an Amarok, but it is a pickup that can remain operational in contexts where a premium pickup would be grounded because of costs or lack of spare parts. In 2026, with high raw material costs and slim margins for end users in practically all emerging markets, that proposal has more value than any 12-inch touchscreen. The Poer is not the most exciting pickup in this ranking. It is probably the most honest. 4. Jac T8 Pro. Aesthetic presence with emerging market logic is an example of how Chinese pickups quickly learned a lesson that the first generations completely ignored. Image matters as much as the product. This is not cynicism. It is an accurate observation about how purchasing psychology works in the pickup segment. The first Chinese pickups that arrived in Latin American, African, and Southeast Asian markets had a problem beyond perceived quality. They had a problem of desirability. They were vehicles that nobody wanted to drive, even though they were functional, because they communicated the wrong message. The pickup buyer, even the work buyer, has an aspirational burden associated with the vehicle. A Hilux is not just a tool, it is also a symbol. Ignoring this was a mistake that cost market share for years. The T8 Pro is the correction of that mistake. Unlike the first generations, which looked like basic utility vehicles with modern bodywork, the T8 Pro bets on an aggressive aesthetic, big grille, sharp headlights, and a visual presence that brings it closer to Western mid-size pickups without directly copying them. It is not just design, it is a positioning strategy. The visual message the T8 Pro gives when parked on the street is that of a serious, capable, modern pickup. And this message arrives before the potential buyer opens the hood or asks the price. Technically, the T8 Pro maintains a conventional architecture, ladder frame chassis, solid rear axle, and connectable 4x4 traction. There is no structural innovation that justifies a headline, but there is gradual improvement in suspension settings and acoustic insulation compared to previous generations. JC understood that the user buying for image also wants their driving experience to validate that image. A pickup that looks premium but sounds like a tin can with every bump loses customers in the second week of use. The goal is that the urban user does not feel like they are driving a rustic vehicle, even if the base is a work pickup, and that is a specific engineering goal. It does not require changing the platform. It requires fine-tuning the bushings, improving cabin coverings, adjusting body resonance frequencies. These are investments not visible in the technical specifications but felt in daily use. Jac's turbo diesel engines are designed for markets where fuel quality is not always the best and maintenance can be irregular. This is an engineering decision rarely mentioned in product reviews because it requires deep knowledge of how a vehicle is operated and maintained outside developed markets. In many target markets for the T8 Pro, diesel has higher sulfur content than ideal for modern high-precision engines. Latest generation common rail injectors are extremely sensitive to fuel quality. An engine calibrated for European fuel can have structural problems after 6 months of use with low-spec African or Latin American diesel. Jac solves this with more conservative injection maps and less demanding thermal management systems than a pickups designed for premium markets. Maximum efficiency is lost, and this shows in lab consumption figures, but tolerance in real use is gained. For the buyer operating in these contexts, it is the right decision, even if that detail never appears in any brochure. The critical point of the T8 Pro lies in the balance between equipment and durability. The more screens, electronic modules, and comfort systems there are, the more potential points of failure exist. This is a mathematical truth that the automotive sector prefers not to communicate to the end customer, but the after-sales managers know it very well. Jac attempts to stay in the middle ground, offering the minimum that the 2026 buyer expects: central screen, basic connectivity, rear-view camera, traction control, without turning the pickup into an electronic device on wheels that requires a certified technician to diagnose why a warning light turned on the dashboard. This decision is not aesthetic, it is industrial. Each additional module increases production costs, spare parts logistics, and technical service expenses. A pickup with 15 electronic modules networked via CAN requires specific diagnostic equipment. A pickup with 6 modules can be diagnosed in 80% of workshops worldwide with generic tools. The real appeal of the T8 Pro is not that it is better than a Hilux by any absolute technical parameter. It is that it offers just enough at a lower price in markets where price difference determines purchase more than any technical specification. In a market where the Hilux costs $45,000 and the T8 Pro costs $28,000, the question is not which is better. The question is how many months of work the difference represents. And in that equation, the T8 Pro wins. It does not compete for brand prestige, it competes for accessibility. And in 2026, in the markets where this pickup is sold, accessibility is the definitive argument. 3. Changan Hunter, the hybrid pickup. The Changan Hunter introduces something different in the segment, light electrification applied to a work pickup. It is not a statement of intent for the future. It is a concrete, available product that puts on the table a question the pickup segment had been avoiding for years. Can electrification work in a heavy-duty work vehicle without becoming a problem? Before answering that question, it is useful to understand exactly what the Hunter's hybrid system is. It is not a pure electric pickup, where all propulsion comes from electric motors powered by a large battery. It is a hybrid scheme, with variants ranging from mild hybrid to PHEV depending on the market, designed for 2 specific objectives: to reduce consumption in urban use and to improve the available torque at low speeds under load conditions. It is not a technological revolution. It is a proof of concept applied to a format that historically was 100% combustion engine and has structural reasons to be so. The Hunter's hybrid system does not seek maximum efficiency in the laboratory. Laboratory tests have standardized cycles that do not represent how a work pickup is used in the real world. What the Hunter aims for is to reduce real consumption in scenarios where pickups spend a lot of time in urban traffic or in short trips with partial loads. And those scenarios are more frequent than the field pickup image suggests. A significant portion of the active pickup fleet is in peri-urban areas, doing distribution or service routes that include lots of slow traffic, frequent starts, and varying loads. In those scenarios, the electric motor helps with starts and maneuvers, where the consumption of a combustion engine is less efficient. A diesel idling consumes fuel to keep running without producing useful work. A hybrid system can shut off the combustion engine during brief stops and use the electric motor to start without that transition cost. In cycles with many stops, this translates into real consumption differences, not marginal ones. The structural problem with electrified pickups is weight. It is not a problem of image or perception. It is physics. Batteries, electric motors, and control systems add mass. In a mid-size pickup, that additional weight can be between 200 and 400 kilos depending on the size of the battery pack. And in a pickup, weight has direct consequences: lower payload capacity, because the chassis's maximum allowable load is shared between the vehicle's mass and what is carried in the bed, or greater structural stress on the chassis and suspension if loaded to maximum without adjusting the theoretical limit. Changan tries to compensate with structural reinforcements and stiffer suspension calibrations, but the reality is that a hybrid pickup will always have compromises compared to a pure diesel in terms of mechanical simplicity. This is not a flaw specific to the Hunter. It is a consequence of adding technology to a platform designed without it. There is another angle that electrification enthusiasts tend to minimize. Hybrid system maintenance adds complexity: more sensors, more power electronics, more high-voltage components, more potential points of failure. In markets with limited technical service, with workshops lacking training in high-voltage systems and the necessary safety equipment, this can become a real risk factor for buyers who prioritize operational availability over marginal efficiency. A pickup halted because the local technician cannot diagnose the battery management system is not efficient, even if it consumes less when running. That said, the Hunter does not exist to replace traditional pickups in all contexts. It exists to test if the market accepts partial electrification in a historically conservative segment, and that experiment has value regardless of the short-term commercial outcome. If the Hunter sells well and its buyers report a good user experience and manageable maintenance costs, it provides Changan and the rest of the Chinese industry with real data on the viability of electrification in pickups. If the experiment fails, If buyers don't renew, if after-sales costs are higher than expected, if batteries show premature degradation under real work conditions. This is also valuable information that allows for correction before making bigger bets. In the automotive industry, controlled experiments cost money, but are worth more than assumptions. And Changan has the financial capacity and large domestic market to absorb that experiment without an adverse result being an existential threat to the brand. If it works, it is likely the rest of the Chinese brands will accelerate similar proposals. If it doesn't, it will remain as an attempt ahead of its time that left valuable lessons. In either case, the Hunter has already fulfilled its most important function. It brought the topic to the table in a segment that refused to discuss it. 2. Foton Tunland G9. The corporate pickup Foton aims the Tunland G9 at a client profile that most pickup analyses systematically ignore: the institutional buyer, not the individual who emotionally chooses their pickup at a dealership. The fleet manager, the operations chief, the purchasing officer of a service company or a public agency that needs to renew 40 units and must justify that investment with numbers, not feelings. That customer exists and purchases many more pickups by decision than any individual buyer. The commercial and corporate fleet parks represent a significant fraction of total sales in the pickup segment in practically all markets, and that customer has completely different needs than the individual user. The G9 positions itself as a compromise product between robustness and industrial standardization. Known architecture turbo diesel engines, no hybrid variants nor technical experiments that complicate the maintenance contract, a conventional automatic transmissions with predictable service intervals, and a comfort level sufficient for long driving days without the driver ending the day with back pain. It does not seek to be the most capable in extreme off-road. It aims to be predictable in operation. And predictable, in the vocabulary of a fleet manager, is exactly what makes a brand win a tender. In fleets, what matters is not the maximum technical sheet, but the predictability of costs. Clear and documented maintenance intervals, guaranteed parts availability through formal channels, short repair times that minimize days the vehicle is out of operation, technical support with geographic coverage in the zones where the fleet operates. None of these variables appear in typical pickup comparisons, but all of them define whether a pickup is suitable for corporate use. Foton deliberately and visibly designs the Tunland with that logic. Parts shared with other models in the group, ensuring spare parts production in volume and lower costs. Simplified architecture that reduces diagnosis time in workshops, and a service network focused on volume-based maintenance contracts. It's not glamorous, it's industrial, and in the fleet market, industrial wins. The fleet approach also explains the equipment of the G9. It is sufficient to meet basic comfort and safety standards: airbags, ABS, stability control, climate control, functional central screen, but without technological excesses that increase maintenance costs. There is a multiplying logic that fleet analysts apply to any equipment decision. If each additional system adds $200 of potential maintenance cost per vehicle in a fleet of 50 units, that additional system costs $10,000 over the life cycle. That math makes fleet managers look very skeptically at premium equipment that has no impact on vehicle productivity. The Tunland G9 does not need to convince the enthusiast who compares power, torque, and acceleration on forums. It needs to convince the purchasing manager that the total cost per operating kilometer over 4 years will be lower than that of competitors. And to make that demonstration, Foton has something many Chinese brands still do not have in all markets: fleet history. Real data on operational availability, maintenance costs, and durability under intensive use conditions. Where it exists, that history is the most powerful commercial argument possible in the corporate segment. It surpasses advertising, specialized magazine awards, and performance comparisons. When the fleet manager can see that the Foton vehicles of the previous company had 96% operational availability over 2 years of use, the discussion about whether the touchscreen is of better quality than the competition becomes irrelevant. The Tunland G9 does not seek to conquer the enthusiast. It seeks to convince the fleet manager. And in the real pickup market, that type of decision moves more volume than individual purchases. Foton knows it, and the G9 is built precisely for that. 1. BYD Shark, the Chinese pickup aiming to redefine the segment. It is the most ambitious bet among Chinese pickups for 2026. And one must understand well what ambitious means in this context, because it does not refer only to technical specifications, it refers to competitive intent. The Shark doesn't only aim to compete on price in the pickup segment, it aims to compete on concept, to change the rules of the game instead of winning within the existing rules. To understand the magnitude of this bet, one must remember what BYD means in 2026. It is not an emerging Chinese brand trying to enter a market that doesn't know it. It is one of the largest electric vehicle companies in the world, with battery development experience that predates its history as a car manufacturer, with global-scale production lines and vertical integration capacity, from the battery cell to energy management software, that no traditional pickup manufacturer has. BYD is not entering the pickup segment without resources. It arrives with structural advantages its competitors cannot replicate in the short term. The Shark has an electrified platform, energy efficiency focus, and positioning closer to technological pickups than to classic utility pickups. This is not a marketing euphemism. It is a difference in architecture. A pickup built from scratch with electrification as part of the base design has engineering trade-offs completely different from a traditional platform pickup to which an electric motor is added as a supplement. In the Shark, weight distribution, traction management, driving modes, and control software architecture are designed with electrification as a central variable, not as an addition. This does not solve all the structural problems of electrified pickups. The battery weight remains a physical reality, but it does allow optimizing solutions that on an adapted platform would be inevitable compromises. BYD isn't entering the segment to copy Hilux or Ranger. It is entering to propose another logic. A logic where the pickup can also be an efficient daily urban vehicle with more comfort, lower consumption in mixed cycles, and an energy efficiency narrative that connects with markets where environmental regulations are starting to weigh even on work vehicles. That logic is not only commercial, it is regulatory. In markets where fleet vehicle emissions have fiscal consequences for companies, a pickup that consumes significantly less has a sales argument that did not previously exist in the segment. The structural problem is the same as for any electrified pickup, and the BYD Shark is not immune to it. Weight, complexity, and infrastructure dependency. A hybrid or electric pickup needs accessible charging points to maximize efficiency. It requires technicians trained in high-voltage systems for specialized maintenance. It requires a more complex after-sales ecosystem than a conventional diesel pickup. In developed markets with mature electric infrastructure, this is viable and operational benefits outweigh the additional costs. In emerging markets with uneven infrastructure, it is a real barrier that can dilute the value proposition in practice. BYD is fully aware that an electrified pickup cannot be launched globally with an immediate volume logic. The Shark's introduction strategy reflects that reading of the context. The first target markets are where charging infrastructure already exists or is rapidly expanding, where regulatory frameworks favor low-emission technologies, and where the buyer profile can absorb a higher initial price without it being a decisive exclusion factor. In these markets, the environmental argument and regulatory compliance weigh significantly in the purchase decision, and electrification is not seen as a technological oddity but as the expected product evolution. This is not a rapid mass market strategy, it is a progressive positioning strategy. BYD does not seek the Shark to compete in volume against traditional diesel pickups in 2026. It seeks for it to become a conceptual reference in markets where the energy transition is already a concrete conversation, then expand gradually into regions with less infrastructure or less demanding regulatory frameworks. The objective is not to conquer all markets simultaneously, but to build technical and commercial legitimacy in the most favorable environments, and use those cases as viability proof. In that sense, evaluating the Shark only by its initial sales figures would be an analytical mistake. Its impact is not measured in units sold in the first year, but in the change in narrative it introduces within the segment. The Shark does not intend to immediately displace models like Hilux, Ranger, or Amarok in markets where electrification still faces practical barriers. What it does do is force other manufacturers to explain why, in a context of growing regulatory pressure and stricter emission reduction targets, they continue to bet exclusively on 100% thermal engines in a segment that moves large volumes and has a relevant environmental footprint. Each BYD launch in traditional segments triggers internal reactions in major automaker groups, not because the product will immediately cannibalize sales, but because it introduces a change in market expectations. Product teams from brands like Toyota, Ford, Volkswagen, or Stellantis do not see the Shark as a short-term threat, but as a signal of where demand may move in the medium term. If BYD's proposition proves functional in real use, the argument that pickup customers don't want electrification quickly loses strength. The strategic value of the Shark lies in anticipating a scenario where electrification ceases to be a niche alternative within the segment and becomes part of the standard offering. In the second half of the decade, it's likely buyers will start considering electrified versions as a first option, not as a technological curiosity. When that happens, part of that perception shift will have been driven by products that dared to challenge the dominant logic before the market explicitly demanded it. Therefore, the real impact of the BYD Shark is not in how many units it sells in 2026, but in how it contributes to redefine what is considered a normal pickup towards 2028 or 2029. That change in buyer expectations once installed is much harder to reverse than any specific sales figure. Chinese pickups are no longer a distant promise nor a market curiosity. In 2026, they are a real alternative for those seeking load capacity, mixed use, and more contained costs compared to traditional options. Each of these proposals responds to a different logic, from classic robustness to partial electrification, and their impact will depend on the real use each buyer gives them. If this analysis helped you better understand where the segment is moving, leave your like, subscribe to the channel, and activate the bell so you don't miss upcoming videos about cars, pickups, and automotive market trends.